Hello everyone, welcome back to Bootcamp workshop number 4. Today we've got Indexing Inc. with Squid.
I'm Vicky Val. I'm co-founder of Coda.art. What's Coda.art? We are a generative NFT marketplace, currently on Polkadot Asset Hub, already supporting EVM plus small surprise on Wasm. We are open source. We have more than 130 plus contributors, 600 plus stars. And why am I here? We are fully powered by Subscript or sqd.dev. And first question is like, how do you get data for the dApp? In general, like when you're building a decentralized application, you don't have any magic server where you can get the data or fetch something or process something. You get the data via the RPC node or remote procedure call calling on the blockchain node. But like there's limitation. The access to the RPC node is usually limited, especially like in the Ethereum ecosystem. You need to use some node providers such as our Infra or Alchemy. Like pros, it's very easy to use. You just install a library, either Ethers or VM or something similar or Polkadot.js, and you can fetch data. And you don't need to rely on any third party. So if there is any outage, you can just switch to other RPC provider and your app works. Because it's not very scalable, if you have like more than 3 users or more than 3 of your friends, it becomes very slow. Plus you can be rate limited on these RPC nodes. Plus you don't have any historical data because anything you get from the RPC node is just the state. You don't have any historical data. So if you want to check like how the balance changed on particular token, you cannot see it either without any database. So why do we need indexer? It's very good and valid question right now. You do not want to sacrifice UX. So we tried like in the first iteration of Coda, like many years ago, just to read from the RPC node, and like what happened, you start to fetch all the possible NFTs, and it took a very long time. So you can make coffee, you can return, and all the data would be still loading. So it's seamless and easy to use, plus it's fast. You can get analytics when you have indexers, so you can make data views, and it's a great way to obtain insights into the data, so you can see like what's the floor of this particular collection, or what's the currently trending collection, or who's the biggest collector of the particular NFTs. There's very nice insights, and you can like see what's going on your platform. Plus, you have a simple GraphQL interface. So instead of like having REST API, which would be not very flexible because also the blockchain data aren't prescribed some way, you can create your own schema and you can model data as you need or as you wish. So that's the nice thing about indexers. And especially in Substrate or in Polkadot SDK, we have 2 types of block of data in each block. First, it's events, and second, it's extrinsics or transactions. So transaction is basically the call you make. So for example, in case of NFTs, you call the palette called, for example, NFTs palette.mint, and it's the result. It makes the transaction. So even if you do like transfer balance or call a smart contract, that's basically extrinsics you're making. Then there's events, and events are basically interactions that are emitted by the chain. So if it's smart contract or if it's like the palette itself, anything that changes states usually should emit event because you should be notified about this state change. So you don't need to track like particular part of the memory of the blockchain. And rule of thumb, it's more effective to process events. We found it out by using Subscript for many years. And events are basically faster and easier to process because they usually contains the data you would really need. And it's easier to work with them. Maybe question now is like, should you code your own indexer? And short answer is please no, unless you don't have any other choice or tech fit, for example, like the indexer technology doesn't work on your particular blockchain, or there is something you would specifically need, like you have ultra hacky devs that knows Elixir and you need to have it in the Elixir instead of the TypeScript. So go for it, but otherwise I wouldn't recommend. It's very hard to process. You would need to like write very hacky ways for the RPC data, and yeah, you would like to focus on your business logic, not on like reinventing wheel. So usually you have two types of indexing solutions. First is like a general, it's for example like Alchemy or Morales. They offer you like this sort of indexing services, or they are sort of data providers. The disadvantage, of course, is a limited set of data, so you can have your like you can fetch NFTs from Alchemy, for example, but you would miss some data, for example, or you want something special, it's harder to make. Then there are custom, usually well known is the Graph, and of course, like the better one is the SQD.dev. And basically, they offer you to index all the possible data you can find on the blockchain. And question is like, what's the difference between the Subscript and the Graph? The image is very well descriptive. The Graph, I use it like in 2019. It's kind of sort of monolith, so you have like this big chunk of application, or how to call it, where you have like built-in Postgres database, GraphQL, and also the subgraph, like the something that's processing your data. It's nice, it's easy to use, but of course you need to sacrifice the thing that, okay, you can only save data to Postgres, or you need to use GraphQL specifically. Plus, it's depending on the archival node, which also, when the archival node goes down, it kind of sucks. On the other hand, Subscript is a very flexible framework. That's why they call it like SDK. And you can take any data you want, process it via the Subscript SDK, and put it into anything you want. So by default, we go with the Postgres database. It's fast, it's flexible. It offers anything you want, but for example, if you have a very specific use case, for example, you want to show your taxes, or you want to do some very specific business queries, you can put it into Google Cloud BigQuery. Or if you need to process like just the metadata or some small packages, you can put it into S3. You are not limited to just Postgres, and it's very flexible. It's very nice. And for example, things we need, or we'll show today, is like how to get IPFS data to the Subscript SDK, combine it with the on-chain data, and create like very functional and seamless app. So how Subscript looks like internally? You have this Subscript SDK or your processor. You can put anything you want there. So if you need like IPFS data, you can do that. If you want like prices for CoinGecko, you can do that. If you have stored your own another API, you can also do that. Then you have like a Subscript archive. It's a basically huge set of workers which are decentralized, and they offer you this sort of chunks of data. So first, millions of blocks can be fetched via these workers. So as the data don't change, the indexer can be like ultra fast, up to like 50k blocks per second, which is like insanely fast. And then like last 10,000 blocks need to go via the RPC node, which ensures like, yeah, you can live index all the data you need. And at the end, you can put it anywhere you want. You can serve it via GraphQL, you can serve it via analytics tool, or other targets, or your sort of databases. To have overview how it look like, it's very complex. I just don't want to deep into that. But you see, you have the Subscript network, which is like a set of workers. You have the gateway, and it basically works by these chunks. So each worker has each chunk. you have smart contract, which has the worker registry, and you can then fetch via the gateway the proper chunks, and yeah, be sure that it works seamlessly. And the dataset could be stored anywhere from S3, IPFS, RV. You can choose. It's very modular. It's very flexible. I'm super bullish that the CEO of Subscript made some magic. And yeah, how does the processing work? So for each batch of blocks, basically you filter out the requested transactions or events. And for each event/transaction, you call the define handler, which we need to define by ourselves. And then basically the task of the handler, it should transform the data to match the schema we have. We'll discuss it later, and we'll save it to Postgres for the sake of simplicity. So we have like full scale production dApp. So let's dive into the Subscript. And let's share the screen. Where's the, sorry, code. Perfect. So we'll start first with our smart contracts, because like we have in workshop, I coded like a sample ERC721 contract, which you can find in that Inc examples. And what I added is basically each contract, basically in like world of NFT marketplaces, has sort of the contract URI, which tells you like this is the contract. This is how it looks. It's like contract metadata, so it has this image. Imagine like Board AF Club. It has name.
I just interrupt you a sec. Could you zoom in a bit on the code?
Is this okay?
Yeah,
or bigger.
Just
okay.
Is that big enough?
Yes.
That should be good. Yeah, thank you.
No, you're welcome. So imagine Board AF Club. You have like this sort of image. You have name. You have description. So this was contract URI does. Then we have the base URI, so we know that each basically NFT, each token has its own sort of own metadata. And you have this base URI, you append the token ID to that, and you can get your own custom metadata. Usually, or the best practice is that the contract URI is stored on IPFS as a JSON. We also have the JSON, of course. And the base URI should be also like the IPFS, where like the IPFS folder with sort of all this routing. But for the sake of simplicity, we'll use web server today. So as I went through the original workshops before by Encode, I didn't see that anyone used string before. So if you need to use strings in Inc, you need to import like this prelude string like this. So you basically cannot use the original Rust string, because like this magic string is using vector of unsigned 8 integers. And yeah, it's more flexible for both tests and the production environment. So we'll just import strings. Then I use it like a contract URI string, base URI string. So it's primitive. It's not some double map or just simple map. It's just string. And yeah, the ERC721 looks normal, like anything else. So now we need to extend the constructor. So instead of like creating the default one, we return like ERC721. Now we define the base URI. For me, I created this one. This should be, I created like base URI. It's string from, it's built into the prelude string. Use this URI for the web server. Then I create the contract URI. It's also a string from this IPFS. How to check the IPFS? It's a good question. You can use like IPFS.io/IPFS and should load, or you can use the coded one. Image should be easier one. Yes, perfect. So this is the IPFS metadata. So as you can see, for our contract, we have defined name of vertices, and also we have image, which is also the IPFS link. This is the description of the collection. Then we have external URL and the type. How did I get these properties? It's defined by OpenSea metadata standard, which we use also in Coda. So it's sort of compatible. And we have this contract URI. And then something which I found out is that you can use these two dots to extend basically the constructor of the contract. So instead of like having default or having mutable contract, you can write it like this. It's more flexible because I just need to define this base URI, contract URI, and then the rest of the storage I want to keep as it was. So I want to have default properties for this token owner, token approvals, blah, blah, blah. So it's very flexible, and usually in 3 lines of code, you have working demo. And what I also coded was how to get the contract URI. It's option string, so you don't need to have this contract URI, but it's nice to have it as a getter. Then I wrote the setter, of course. So it's just basically setting contract URI, and of course I've written the token URI. It's the standard in the EVM world that is usually written like token and URI all big. And basically I'm returning currently as a tuple. There will be homework, don't worry for this. And also I have setter for the base URI. So let's compile that. Cargo contract build -- release. As you can see, I built it before. Perfect. So we can open that now. Let's go to the UI that use ink. For today's purposes, we use Aleph0 testnet. You can get testnet tokens very easily. I'll share the link. So let's add new contract. Let's upload it and code one. Upload the bundle. So it's already uploaded, I guess. Yes, I need to forget this one. So add new contract, upload the code, and code one. And we can now upload the contract. So we do now release, approve. Perfect. So now we have our contract, which is basically ERC721 written in ink. We have this magic address, and the caller, of course, is me. A message we're gonna send is, of course, mint function. So what mint function does, basically takes the token ID and creates it creates a new token for us. So let's call it. It's annoying. Yes, so now you see it was successful. Now it's contract diverted because the token already exists. But if I add one here, I would have a new one. So let's do that a few more times. Can I maybe use it like this? Perfect. So we have at least 4 tokens. Perfect. So now we have 4 tokens, and you can see like we can get the get contract URI is the IPFS we have. If we want to get the token URI for the current ID, it's just returned as a tuple currently. For the sake of simplicity, we have this hard coded. This is like 0, the token URI. This is how it works. And since we have a smart contract, we can check it on the Aleph0 testnet. If it's there, yep, it's there. So 1 minute ago, and so on. So let's index it. We have 4 NFTs, so we can index that. So let's copy it. And what we now need to do is we need to do one very specific thing, which I can explain, but can't tell you why. We need to convert this address to the public key so it can be indexed by the Subscript, because like how Subscript operates on basically Inc smart contract, it doesn't index that by their addresses, it indexes them by the public key. So it's more versatile. So we need to copy this and let's go to the Subscript. So one thing, so we don't forget, it's just we have this address currently, and we need to. So this is my current setup. We're gonna use the Aleph0 testnet. We use the archive URL. As I explained, it's the set of gateway for these workers. It has this name like Aleph0 testnet, so I use this. You can use also Offstar, you can use the Aleph0 mainnet, you can use Shibuya, whatever works for you. We need to set like a node URL, so our RPC node, to fetch this last 10,000 blocks. We need to then, I'm usually using the starting block because we're gonna index just one contract, so we don't need to start from block number 0 and block number 1. It saves our time, so we're gonna check when the contract was instantiated. This, you basically click here, copy here, the block. You see that there was a contract call, and we'll replace it. This basically saves us a lot of time of indexing time, so it will go faster, of course. So we'll have now the starting block, the contract address. Usually what I'm doing also is console.table. So anytime I'm debugging or changing something, it's nice to have this nice input that I know that, okay, I'm correctly setting the chain, I'm correctly setting the archive URL, the RPC node, starting block, and of course I can recheck the contract address. So when all this magic starts is in the processor, usually. So what does all this magic do? Is basically we create the new Substrate batch processor we'll import it from the Subscript/batch processor. If you need to know where this from, there is a repo or template from Subscript. I also provide the link. I also provide a link for this one, so you have like real world use case. So we start with the Substrate batch processor. We need to define like which gateway we are going to use. In our case, is the Aleph0 testnet gateway. We have set the block range from, and also define like if we need to. So if you basically need just a few thousand blocks to index, you don't need to run it indefinitely. You can set the block range as you need. It's very flexible. That's why I like love it. Do what you need. Then we need to set the RPC endpoint. If you don't need to have live data, you can skip it. But usually, as a real world use case, you would need that. We'll define the node URL. In our case, is the A0 testnet. And then we have the rate limit, so we don't basically get banned. Usually the rate limit of 10, 15, max 20 is okay, but usually like safe bet is to have 10. And then we need to define like what we're gonna index. So in our case, we're gonna call this like add contract emitted. So it knows that basically we're gonna index something that happened on the contract, because as we learned, contracts in the substrate are basically pallets with a building like WebAssembly code. So this like add contracts emitted, and from the address of this contract address is a very big hex. And what we need to define is we want also the extrinsics. We can also have another things, such as if we need like events, if we need something else, extrinsic is okay. And then we need to define which fields from that block we need. And it's done via the set fields. And in my case, it's kind of big one. It's usually what I'm using for all the indexers. So rather than selecting all fields from the subscript, we want to like cherry pick the fields we need. Why is that so? Is that we don't want to overfetch the data we have. Of course, like each batch fetches the data, and more data we fetch, the request is also bigger. And the request is bigger, it takes more memory to process. Yeah, Squid can get slower and so on. So I'm just picking up the data we need, and in my case is that from the block, I'm just getting the timestamp. Can get more data. It's up to you. I'm using the timestamp because I want to know when it happens. From the extrinsics, I'm taking the signature, so I can know what's the address of the caller, so who called that function. And also I'm taking the call, so I know that what was the origin of the call. In this case, it doesn't make much sense because it was always contracts palette.call on the particular smart contract. This also was the argument, and we also know what was the origin of the contract. So it's useful when you have, like, for example, the batch calls, or when you have the proxy multisig. It's nice to play with that, so you know what was the like real origin of the call. So especially in the proxies or utility derive, it's nice to see what was the real origin and not the like proxy. And mainly why we are here today is we are selecting the events. I should make it bigger. Sorry for that. So we are taking the topics. It's basically the name of the event. The name is more or less contract emitted, and we also want like arguments of the event. So when you have like event with the parameters, we need to know like what the parameters are. So this is what we are selecting. And when we have this processor, we just set these fields and our processor is ready. It looks like a magic, and in 15 lines of code, minus the comments, you define that you want to index this chain from this block, and I'm interested in this particular contract, and that's done. And how to run it? There is magic file called the main.ts where all it starts, and we need to import the database. We import like how we're gonna index all the stuff, and like which processor is going to do that. So we just create a new database. Usually in case of Subscript, or in our case is the Postgres. If you need live data, you can make a support hotblocks.true, and you would have the hotblocks. I'm usually turning it off just for the sake that I'm also doing we are doing very weird SQL transformations, which are not very friendly with hotblocks. So we usually turn it off. But if you need like hotblocks by default, hotblocks are the blocks that are not included into the state already. Like they are not finalized, but they are like in blocks. Also, like if something like reorg happen, Subscript handles it automatically, so you don't need to take care of it at all. That's something like with one line of code, you have it there instantly. It's amazing. So we'll turn off the hotblocks, and then all magic starts is on that processor we defined. We call run. Our database is basically the database, which we define here, and we'll call function called mainframe. It's my naming that I'm usually not lost in all the code. Squid can get really big, So that's why I organized it into like small files. And when the processor run starts, it will call the mainframe. So we can make format. Also, you see here is also 3 lines of code. We'll do a lot of imports, which are not fancy. So as an argument of mainframe, we are getting this context, this type of process. And you see that this process has like blocks, it has extrinsic, it has calls, it has events, anything you need. So for first, we log some info that we are processing these blocks from 2. And first, what we are doing, we skip this if statement. We'll explain it later. And as you can see, for the batch of blocks is the context.blocks. We'll take the events, and for each event, which is binary contract emitted, and the event that asks contract equals to the contract address, we'll call this handler. So we'll by one event, we are basically creating this calling this handler. Why I skip the if statement is that how do you know that how data should look like? It's very good and it's on point to create it now. So what we are doing is like before you start creating this sort of Squid, or you can start with writing Squid first and then create your schema. That's also usually approach, the hacky one. This is the schema we use in Coda. It's called the universal schema, and this is how we define these entities in Subscript. So first, I have the collection entity type, which basically you can imagine that my ERC721 contract is this collection entity. So it basically, every contract is a collection because it has a list of all the NFTs inside of it. And for that, I have a few fields. So in my case, it's a block number. It's where it was created, was the owner, a lot of stuff. What's interesting here is line 19 is it's like each collection has basically the array of NFT entity, and this means that it cannot be null. Basically, without that, you can say like, okay, it's optional. Without it, you have to say it exists. So for us, it's like save mechanism. If, for example, something in the entity would be null, the database would automatically fail. So let's go to the NFT entity, how it's defined. It's also huge kind of entity. Also, I had defined like the block number burned. Also, I have linked to the collection entity above, so I know like directly from the NFT entity that, okay, I can access this collection. I have created that owner. Also, I have array of events, so I know when it was created, when it was transferred, when it was burned. I have ID. I also store the image. And as I said, special thing about Subscript is that you can use any other external data from IPFS to external servers. So I created something called Meta, which is type of metadata entity, and we know we know that it can be either null or something. So we define the metadata entity, which basically would be the JSON we have seen before. The metadata is basically string, so if there will be mismatch between the metadata entity and metadata, you will find it out. I have it just for the sake of this incoherence. It happened to me a few times that the metadata link basically saved me for debugging purposes. I have also name. Why do I have an index here? it's anytime you have this at index, you basically are saying to the database that this basically column is very important. Create index out of that. And why do we need indices? It's basically when you are doing any operations such as like searching, sorting, filtering, having index on that field basically make all these operations faster. You basically cannot put it on every field. Why? Because with index, anytime you update the database, your database need to recalculate the field on the indexes. It became slow, so just use it wisely. So that's why I'm using on the current owner. I use it on the metadata. There are fields we use it regularly for searching. We use it regularly for sorting. You can also put price there. It's up to you. You need to take the trade-off. And then you have the metadata entity, which is kind of important. Then you have the ID, which basically could be any string. Then we have also name, description, image, attributes, the animation URL if it's defined, and the type. So we have now the schema. And what to do with the schema is basically we need to transform it into something very friendly. So for that, I delete this folder, so you will see it. There is module generated. Yes. So what I have just removed is something, or why Subscript is so amazing, is that you can generate like TypeScript types for this schema. So by just creating I forgot the original code. So just type npx squid -type orem -code gen. Nice. We'll create like these generated types, and you can access it on the source. Okay, collection and even collection entity. So you can see that from that schema you've seen, we got collection entity. So instead of writing this heavy magic, which could be hard to process, it's basically the TypeScript code, which is compatible with the type ORM. ORM is like object relation model. What it means that this basically like TypeScript representation of your database entity. So you don't need to make it manually. Subscript can make it for you. It's awesome. So you see that we have this type collection entity, and by each block number, created at, current owner, everything is here. You'll see that if enullable true or false based on here. So it's very flexible. It's easy to use. You don't need to write it manually. And why do we need that? Instead of like writing raw queries to the Postgres, it would be very annoying to make insert into collection entities, insert values, blah, 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 blah. You can create the object of the collection entity and save it to the database. So how it works, let's dive in. So we had that index.ts, which we skipped. And since I'm not indexing the creation of the contract itself, you can do that. By the sake of simplicity of this tutorial, I skip that. I basically have this list of contracts. There is basically just one contract which we define. So this is the contract address, and I basically hardcode the values for the simplicity of everything. We'll basically create a collection based on the collection string, and I'm checking like if it is a contract map that via the contract address, you will get that. we append also base URI, also for the sake of purposes. And if it's there in that contract list, we basically call the create on a collection entity. The ID is basically the collection itself, and this is like the predefined values. Where is this create from? It's a very good question. I create for myself and our members a package called the Squid, so you can use it. Also, I link it. It's very easy to use. It's basically like sort of wrappers around the existing Subscript features. So you don't need this. It just for my own simplicity, it was easier to play with this to create this sort of helpers. So we'll create the entity, and what the create basically does, we are telling that, okay, create the collection entity. It's just a different import. So this collection entity we've seen here, create this collection entity with this ID, predefine this data. So you see it will have by default the name, max symbol, who is the owner, was the metadata, and so on. So we have this collection by first, and then we know that once the collection is created, why we need to create this is because, as you remember, each NFT entity needs that collection has to be created. It cannot be like NFT entity without collection. You can also do that by RPC. Subscript allows that. It just, how I use it for the tutorial. So once we have created collection, we can basically check that. So how to start with the Subscript? First, you need to pull your Docker image using Docker compose pull. Then we just do Docker compose up. It's already running. So we done Docker compose down, Docker compose up. So what it does, it runs the Postgres database into the Docker. It's easy to use. Why Docker? I just can remove it, recreate it again. It works. So once I have this database running, I need to build a project first. So using the npm run build, I'm just building the project. What it just does is basically wrap around many commands I've used. And we need to basically now map this sort of schema into the database, because now the database doesn't know anything about what collection entity is, what the NFT entity is. It's done by npx Squid type or a migration apply. And what it does is basically apply all the migrations to create a migration before you don't have any. It's update db. It's a npx Squid type or a migration generate, and you see I don't have any changes to create the migration, but if I would have, it would create this migration file, which can be found in db migrations, and you see that it creates this magic query for create table, create index, alter table. So anything we need, it's very flexible. We don't need to touch any of this code. We don't need to write this manually. It saves so much time. It's amazing. So now we have the data. Now we have the data. So let's process it. So it cleans the project, build, migrates, applies the migration, and as you can see, perfect. So first you see the table, which I console logged before. using allow0 testnet, we use the archive URL, node, starting block with define, and the contract. So you see that we cached one collection, that was that first if, and then we basically logging that contracts emitted and on this address. So as you can see, it's already working, and we'll dive into the last part of the code. So as you may know, we are just interested, basically, anytime you operate with ERC721, it's basically you are doing transfers. And basically minting NFT means transferring NFT from the address 0 or non-existent address to some user. Transferring NFT is basically transfer from user to another user. And burning is also sending from one user or the current owner to the 0 address. So we need to find out like what kind of transfer is that, and based on that we're gonna create the schema. So let's check the last part of the code. As you can see, this is the logger we see, so it's contracts emitted. That's correct. Is the contract we need? Yes, that's correct. So it called the handler. The handler basically what it does is basically it unwraps the event itself. We know that we are now 100% sure that it's event, so we can unwrap it using something we call the decode event. This decode event is basically taking that item arg, args the data that we define in the fields and logs event.topics, basically also what we defined in that field selection, if you remember. So these topics, that event, and the arguments. And we call now the decode event. And how I get the decode event in the first place, it's also something that Subscript is amazing at. I have something here called ERC721.json. I obtained this ERC721.json from the cargo build. So you take that JSON, if you remember, cargo build/release. So you see that ERC721.json, that's the contract metadata. You take it, you put it into the subscript, and now you can do the same as with the schema. You can do that the same on the contract metadata, and that's ultra amazing. So you get this TypeScript file, and to generate it, you called, I sometimes forget this, yes, just ESP721. So it's npx subscript inc typegen, and as the API you see take that ERC721, and as the output is that ERC721.ts, and we regenerate it again, ERC721.ts. Perfect. So now you, from the contract API, you have the TypeScript entities, which is amazing. You don't need to process that manually. It's like breeze. And now with everything you have here, it also creates the function called decode event. It takes some bytes, it takes the topics. As you can see, I just put wrapper around that, so I'm sure that this is basically decode event for ERC721.event, and we see that for ERC721.event, it could be either approval for all, and transfer. I'm interested currently in transfer. You can also do approvals, whatever you like. So we have this decode event, and you have this decode event. The result of the decode event is basically the thing we've seen on the console log. So it's a transfer, and it tells us, yeah, it's kind of transfer. It could be the approval or approval for all based on the decode. And the fields are from, to an ID, so as defined in the Inc smart contract. So as you see, from is the address 0, so it's hex with all the zeros. From to, it's to my address, and the token ID is 0. So now we know what the kind of the transfer is, and we know that what is this transfer is basically, as we defined, if the address from is empty, it's mint. If the address to is empty, it's basically burn. Anything else, it's basically transfer. Based on this knowledge, we basically use the specific handler. So for our case, is the mint interaction. We call the handle token create. For interaction burn, we will call burn, and for the send, we will call transfer. So the last thing you would need basically in Subscript is this handler. So as you can see, I'm using a lot of logs. It's also very helpful. Use it. Logs are your friends. So there is a pending operation of mint at this block. We'll decode it one more time. It's not very good how it's implemented, but works. And we need to check one more time if it's not transferred, then we don't process it. We need to take the contract, and to take the contract address, you've seen it already once. It's basically event.args.contract. I also repeated the function with less verbose. Then we are basically creating the token ID. So basically, we just append the contract and the event.id. So it would be the contract address -0 would be the ID. And then why I told you that we are extracting also specific fields from the Subscript is basically because of this function. As you remember, we use the extrinsic signature dot address. You can use that. You will find the address who was the caller. So in case it was my address, we then format it using the address of function from this hex to the normal address. So I use Polkadot in this case. You can use any SS58 you want. Then I'm taking the block number, and then I'm taking the timestamp. So I have all this base data. And then basically I'm getting the collection. As you can see, also I'm using this get optional. It's also from the Metasquid /entity. So from this store object, so the store is basically the connection to the Postgres database. So context.store, we want a collection entity. By ID is the ID of the contract. So if it either returns, as you can see, either the collection entity or undefined. If the collection doesn't exist, we don't have any incentive to basically index this NFT. So we log the word and return. And if it exists, basically we call again the create function. As you can see, we are now doing the NFT entity with this ID. The pre-fill data I left empty because I wanted to show you that it's flexible. You don't need to use this. You can use it manually if it's more readable for you, or if it's more flexible for you, it's up to you. I'm assigning the ID, assigning the issuer. So in our case, the issuer of the NFT is the one who called the mint function. So it's the caller. Then the current owner is basically the event.to. So from that event, in the block number, we take also the base block number. The collection is assigned like easy as it is here. We use the whole object. Then the serial number of NFT is basically the event.id. So in our case was 0. Then we set the price, created that, and so on and so on. And one very specific thing why Subscript is so amazing at this is we can take the metadata. So as you can see on the line 50, we create the token URI. It basically takes that base URI, appends the serial number. So in this case, we have it like that. And there is one if statement. If final.metadata exists, we'll basically call our API to get the metadata. It returns the JSON. The JSON will append to the .meta because it's metadata entity. As you can see, it's optional, so it's either metadata entity or null. Also, we append the name, image, animation URL, and tada, we have really existing metadata directly from the Subscript. So no overfetching from front end, no any sort of magic. It simply works. And once everything like this is done, we create the success log of operation. We save it like we had the context store. As I told you, the context store is a connection to the database. It has a lot of these things, such as save, upsert, delete, and so on. A lot of these things, basically get optional, create, are basically wrappers around context.store. So you can use it manually. I just do it because it's less verbose. So we save first the object itself. So it's our NFT. In the context store.save, we save the collection because we also mutated the collection. So we updated it, increased the count, increased the supply, and last thing, we emit the event also for us. So for the historical purposes, you see the events. So for this NFT, this operation was mint with some base data and so on. So if we run it, you see basically everything that happened was from the contract emitted. What is this transfer? It's basically mint. Why? Because if you format all the zeros with the SS58, I can show you it here. Oh, prefix 1 isn't here. So I use the prefix 1. It would be that address 6 and something. So I know that this mint, basically that's how it is. 2, this is my address in the SS58 of 1. We see that mint is pending. I saved the metadata. It was done in less than half a second. And we see that the process was successful, the mint of this ID. So we can let it run for a few more times. It's already indexed this first. I just want to have more data currently in 1, 2, 3. Yes, and that's it. We index everything. And you can see it's like kind of fast. It's processing the 10 blocks. And from the point we started to the end, it's 11 minutes. So it's absolutely fantastic. And the last thing I want to show you, promise, is how to get this data for your front end. You use a built-in GraphQL server. It's using just serve, and it's listening on the port 4350/GraphQL. And GraphQL is the topic itself, so I'll show you. We use ID name. It's our collection as we had it. This is the ID of the contract, name of vertices. It has its own max. It has the NFT count. It's 4. Supply is 4. And by the schema definition we had was the NFTs. From the NFTs, we want to take the serial number. We want to take the name. We want to take the metadata, and we can also take the metadata entity itself. So there could be description, and there could be the image. Boom. And by this query, we selected all collection entities with all NFTs. I can make it also bigger. And you see that The serial number is 0, the name is vortex is 0, metadata is here, this is the description, image. So we can take that image now. Ta-da. If we put 1, the image would be different. If we put 2, the image would be different. 3, different. So we have successfully implemented the Coda art compatible Subscript using Ink. And as you can see, Subscript is ultra amazing framework. That's why I wanted to do this workshop. And yeah, if you have any questions, feel free to ask. How do I stop it? Sure, stop. Perfect.
Thank you very much, Vicky, for that session. We have got one question in the question tab. Are you able to see that?
Yeah.
I'll put it on the screen for the recording.
What's the role of Postgres playing in this? So basically Postgres is basically the, if you've seen the slides, it's basically like our end database where we are storing the data. You can use anything you want, as you can see the S3, you can use IPFS, you can actually save it to the Excel file. So if you just want to sort your taxes, I've seen people just using Subscript to write simple script, take their transactions, and put it into the Excel file, send it to their accountant, and that's it. Like, it's amazing as it is. So we use Postgres for our purposes. It's something that you want to use for the production database, but you can use anything you want. That's why Subscript like SDK is that flexible, and it's amazing. You can use any sort of database. If you just decide to use Redis, like key value storage, you can use that. If you decide to use Supabase, I've seen already people using Supabase with that. And
nice. Got another question.
what's the difference between Dune Analytics to Squid? Squid is basically the whole framework / library to index your own data. Dune Analytics is something that you basically, as far as I remember, or am I correct, you need to load your data there, and then you can play with that. So you need to sign in for the pro mode, you need to put there your data, but you can use it actually you can index it via Squid and put it to the Dune Analytics. Dune Analytics basically offers you to create this sort of fancy UIs with all the data you need. If you have any specific use case, you basically can spin up your Squid, use the analytics, and make your own data. So also, same as I said in the presentation, you can use Dune Analytics to query the data, but it wouldn't be that flexible as we would need. For example, I can probably hack NFT marketplace on top of Dune Analytics Substrate API, but I'm not sure if I find Ink, for example, smart contracts there. So that's why I spinned up my indexer in my contract. It was in matter of 1 minute, I had all the NFTs I created, and in 300 lines of code, I have fully working product.
Nice. Eric is typing in the chat, but we've got no more questions. Just while they finish that, possibly with a question, are there any useful documentations or links that you can suggest for everyone to take a look at?
Yeah, I actually I took myself a challenge. I wrote the first version of the Ink Subscript like almost 2 years ago when there was like Ink version 3. And I was like said, okay, let's re-implement this with the Ink version 5 and all the other stuff. So there is my own GitHub repo.
Nice.
And as you can see in the pull request, you see what's changed. I'll put it into the link. And as a homework, I have like really nice challenge. I will also upload the smart contract, so you will need it. It would be also linked into the Mimic repo, so it's visible to everyone. And what's the task? As you can see, I can share the screen again. Can I? No, I cannot share the VS Code. It's sad. Oop. Code. This. Perfect. So see, it's already indexed as we spoke. So what would be your homework? Is basically I have a few bugs here in this code. First, the token URI currently returns the option and the tuple of string and the token ID, which is very bad. And the task is basically to take the base URI plus slash, if the slash exists, and the token ID and return URI. So instead of option string of the tuple, I want to have it like this. So you see it would, of course, fail because it's different types. So it would be the first task. And the second task, as you can see, there is a get construct URI and set construct URI, which is, of course, correctly implemented. But as we learned that anytime something happens on the smart contract, you would like to be notified about that. And your task basically now would be to create when set or URI is set, emit a new event called contract updated and index it with the Squid. So you will know that when the contract URI change, so the basically metadata for the collection, as you remember, you can change the metadata on the fly. So you don't need to manually update your database. You don't need to manually do this. You can index with the Squid. As you emit the event, you check if it was this particular event, and you can update the metadata. Also with the IPFS, you can fetch it directly, so you'll update metadata on the fly. So that will be the task for the Subscript. It's funny. It's nice to think about things. I also link it. There is a EIP in the Ethereum ecosystem for the contract URI, so I link it. You would have it there in the whole repo.
Thank you very much. That sounds like a fun homework for you guys to do, and I'd love to know what your progress is in the Discord channel. Maybe we'll share a solution at a later date. Vicky, do you think you could set up a sort of?
Yeah, I'm gonna link it to the original like mimic indexer. So
Nice.
need to create repo for all the stuff because currently it was just quickly hacked into the ink example. So
Nice. Thank you very much. Okay, we'll end the session here for today. Thank you everyone for joining us for workshop 4. You're over halfway through the bootcamp, which is exciting. Only 3 more workshops to go. I hope you're looking forward to them all. We'll leave it there for today, unless anyone else. Oh, contact links. Do you have any?
Yeah. Anywhere as at VikiVal. So also on the GitHub, on X, like everywhere you can think of, just VikiVal.
Lucky you. Same link for everything. Impressive. Okay, awesome. I'll put the.
And fun fact, I have also like a personal domain called vic.inc. So
Nice. We'll put all of the relevant links in the recording of this video, everyone. So don't worry about copying them down now, including, well, your profile for everything at VikiVal. Other than that, let's leave it there for today. Thank you again for joining us, Vicky. It was a really, really interesting session, really useful. And good luck with the homework, everyone. I'm looking forward to seeing what you do.
Yeah,
Bye,
good
everyone.
luck. Bye-bye.